The two conditions that you're comparing when studying attention are usually when the same stimulus is attended versus unattended. With humans, instructing them to attend a particular stimulus based on a cue is easy. With non-human primates, the task is more difficult. There has to be an advantage for the animal to attend to the cued location. This is done by providing a valid cue, meaning that the majority of the time the event the animal needs to judge or respond to will occur at the cued location and not elsewhere. Over many training sessions, the animal will learn to direct their attention based on the cue. You can test whether the animal is attending the cued location by comparing performance on cued trials to trials without a cue, or trials with a valid cue to ones with an invalid cue. If the animal is in fact attending the cued location, they should have better performance, as measured by a higher percentage of correct trials, lower perceptual thresholds at that location, and/or faster reaction times. You can also keep the cue consistent for many trials in a row, referred to as a block, rather than giving a different cue every trial. This is usually easier for an animal to perform. So here's an example task that macaque monkeys can be trained to perform. This is an orientation change detection task with an 80% valid cue location. Two oriented gratings flash on and off repeatedly for a different length of time on each trial. Eventually, one of them changes orientation. The monkey moves their eyes to the stimulus that changed to receive a reward. Now, let's look at a plot showing the animal's performance on this task. This plot is showing percent correct on the y-axis as a function of the size of orientation change on the x-axis. Not surprisingly, the monkey does much better at detecting very large changes, up to 100% correct. And at some point, the change is so small that they really never notice it, performance dropping down to 0%. Now, we can compare the animal's ability to detect changes for valid versus invalid cues. We can compare what size of change produces the same performance when the stimulus is cued and attended or unattended. In this case, the animal detects the change about 40% of the time for changes of 10 degrees when unattended. But with attention, the animal reaches the same level of performance for a much smaller change, about 2 degrees to reach the same performance. Another way we can measure the effect of the cue is to look at performance for one size of change for cued versus uncued. In this example, for a 10-degree change, which the monkey almost always detects at the attended location, greater than 90% correct, the animal only detects the same size change at the unattended location less than half the time. So here we have behavioral evidence that the animal is directing their attention based on the cue. That will be important when we go to study the neural responses which underlie this behavioral difference for the attended versus unattended locations.